In each sequence, there's 6 hops, and in each sequence, there's 3 hops up and 3 hops down. In order for you to get back, or the bunny to get back on the ground. Okay, so obviously, a simple way is just counting these sequences one by one, these valid sequences one by one, and finding the solution. But this isn't the best strategy because if you think about it, you might miss some sequences, and it will take a decent amount of time to count it. But anyways, let's start with a different solution that's more logical and pretty simple as well. So we have 3 hops up and 3 hops down, and this is our sequence chart. So our sequence chart, this is the first step or the first move. This is the second move. This is the third move, and this is just the or hops. This is the fourth hop. This is the fifth hop, and this is the sixth hop. So we can imagine putting U's for hops up and D's for hops down. And we already have some restrictions. The first hop has to go up because if you think about it, oops. Because if you think about it, the rabbit is starting on the ground. It can't go below the ground. So the first hop has to be up. And if you think about it, this hop or the last hop has to go down because if it's going up, you're below the ground. And then you're going up to the ground, which is not possible. So we already have some restrictions, and now we have 2 U's and 2 D's to place. So how do you place these U's and D's? Well, there's four factorial ways to place an arrangement of letters, but since the arrangement of these 2 letters, the 2 U's and 2 D's, are overcounting because the U's are the same and the D's are the same, we divide by 2 factorial and 2 factorial, and we get 6. And obviously, you can just count it yourself as well pretty simply. You can just put U's right here and then D's right here or whatever. But there will be 6 ways to arrange 2 U's and 2 D's in these 4 slots. But wait, there's one more step. If you think about it, there can't be one of the options, because if you think about it, if the first step is the U and the second step is a D and the third step is a D, that means again the rabbit is going to go below the floor, the ground. So if he goes up one and then he goes down to the ground and he goes below the ground, that won't work. And thankfully, there's only one arrangement that has that, which is these 2 D's and then these 2 U's afterwards. So we have to subtract 1 and we get 5. So there's 5 sequences which work, and the answer would be B. So this is very important, not drawn to scale. This is where many students are thrown off during the competition and will think, well, just use the figure and see which one's the shortest. And that will be wrong. So what's the best solution here? Well, in my personal opinion, unlike the other problem where we used a method instead of just counting, in this problem, it's easier just to find the best route and just to look at it and test different scenarios. So in this case, the shortest route is A to X to M to Y to Z to C and then to Z. And that is the shortest route, and you can just see the numbers. And what I like to do is just eliminate these larger numbers. If you do for searching at like 32 or something, or even 31, let's say you get 31 as an answer choice, then you can eliminate 32, and you can keep on trying to get the smallest or the shortest distance. And in this case, again, it's a to x because that's only 5. So we're trying to achieve the shortest. So 5, 2, 6, 5, 10. Those are extremely small numbers, and is the reason why it is the shortest. So we can just add it up. 5 plus 2 is 7, plus 6 is 13, plus 5 is 18, plus 10 is equal to 28. And it says the greatest number. So we know that the greatest number would be 124, 124. And the reason why I know this is because this is a 6-digit number. This is also a 6-digit number. So if you multiply flies is the greatest it can be is 124, 124. And we don't even know if that works yet. But if we multiply by 8, it still has to be multiply fly by 8, it still has to be a 6-digit number. And this is the highest a 6-digit number fly can be. And if we go up one with the ones digit and the thousands digit, it would be 125, 125. But if you multiply by 8, it will be 7 digits. Okay. So now we know that this is the greatest number it can be, but it doesn't satisfy the equation. And you can multiply by 8 and let me see, 3, 16, 9, 1, 9, 2, 3, 9, 8, 9. Yeah, I think that's it. But it doesn't satisfy the equation because BU and G are distinct digits. So that does not satisfy the equation. But if we go down one, decrease the thousands digit and the units digit by 1, we find that it does satisfy the equation. So we multiply this by 8, and we get to 16, 8, 1, 9, and then 4, 8, 9. Correct. 984, 984. And as you see here, B, U, G are distinct digits. B is 9, U is 8, and G is 4. That's what we're looking for. So these are all they satisfy the requirements of the problem. See, fly, bug are distinct digits, and fly is also distinct digits, and it's the greatest number possible. So we just have to add up the value of fly and bug, which is 1, 2, and 3. 1 plus 2 plus. So we add up 1, 2, 3 plus 9, 8, 4, and we get 1107. I believe, yeah, 1107. And that's an answer choice C.